Hey guys, so today we'll be discussing the question called serialize and deserialize a binary tree. Now, in this given question, what might eventually happen is that let's say that you're given a binary tree. What you need to eventually do is that you need to convert a tree into a compact data structure or something which can be used to send across which can be stored in a file or a memory buffer, and then it can be transmitted across a network connection. Now, I will introduce. I actually wanted to read more about the question, but let me introduce what is the traditional problem. Let's say that you are dealing with a tree. Okay, I'll just draw a basic tree over here. The basic tree will have a root node, it will have a left node, and it will have a right node. Now, what might eventually happen is that you might need, see, this is a tree which is sitting on a computer one. Okay. Now, there might be another computer two. Now, what might happen is that you need to transfer this tree to computer two over here, right? Now, you might think that, hey, what if I send the root of the tree? Now, let's say that you send a root of the tree, but how will we say that ki, hey, C2 does not have the memory access of this, right? So let's say that the tree was stored in some memory, right? And the A was stored over some address 0x01 and B was stored at the address of 0x002, something like that. I'm just drawing a rough. So what might happen is that since C2 does not have the memory access, it cannot traverse the tree, right? It cannot traverse the tree. Think for yourself. Then it becomes very obvious that we need to send the entire tree. We do not need to send the address, we need to send the entire tree. So how will we able to achieve that? Now let's try to understand how will we achieve that thing. Okay. Now the thing over here is that let this tree will consist a lot of nodes. Now let's say that somehow we encode this tree or serialize this tree and store in a form of a box. Let's say that black box. We are not going to deep dive. And let's say that we somehow are able to store in this black box, and we then transmit all the bits across the computer 1 to computer 2, and now we give some logic to computer C2. We give some logic also to how to decode this, right? The information. We are saying that, hey, computer 2, I'm sending you some data, and this is the logic, or we can have some common agreement via which you can decode this given bits. So now the C2 can use the same logic and then try to decode this entire tree, and then it can the C2 can build this tree entirely. So this is how this question is gonna work. Now let's try to understand that since we now understand the real world application for this, let's go and understand how we can actually solve this given problem. Now what can happen over here is that let's say that whenever I try to solve a problem, right, always think in the term of a basic data structure. Like, do not try to complicate it. That's how you're going to develop your thinking skills over here. Let's say that we are traversing a tree, right? And let's say that tree will have a left node and root node and a right node. So we need to convert this given tree into some format. Now let's say that we do some like root, left, and right logic. So pre-order traversal we are doing a pre-order traversal. Now what might happen over here is that A will be the root, B will be the left, and right will be C. So now we need to convert this. Now we need to convert. We have converted this. Uh, we have just stored the value, right? Now let's say that we convert this to a string because that's what the question is asking. You have to encode a tree to a given single string. Now let's say that we have encoded this into a single string, and now we are sending it across another computer. And but how will be this computer decode this? So we told the logic is root left right. Okay, the computer will say that okay, I will try to figure out. So the computer 2 will read A and it will construct the root. The computer will read B and then it will push up the left, and similarly it will generate the right node of the tree. Now what might happen over here is that once you have generated the entire tree, there can be some corner cases as well. Okay, because now it looks very simple, but I will tell you what is the problem with this given approach. So what might happen is that, let's say for a given example, that the right node of this given tree does not exist, and let's first try to delete the entire tree. I mean this structure of this. So we might have something like, I'm going to add some extra node over here. Okay, the extra node will be as follows over here. It will be C, it will be D. Okay, this is a new and this is null. So the thing over here is that if we have pointed a null, like this will be null and this will be, the left and right will be null, this will be null, and this will be null. Okay, so we have around 5 null over here. Now the thing over here is that since we have 5 null, now we need some way to represent this null as well, because if we do not represent it, I will tell you what's the problem. You will start encoding this tree. We will visit the root, then we will visit the left. Again, we'll visit the left, which is C, okay, which is C, and after that we will visit the right. Now, if you send the same thing in a string format to the computer C2, the computer C2 will say that, oh, this is the root, oh, this is the left node, and oh, this is the right node of this A. So this becomes problematic. That's why we cannot, we need to be very careful while handling this kind of pieces. So one way is that if somehow we are able to store the null value in this given string, then a whole question gets solved. That's right, the whole question gets solved. So the entire game is of this given question is of two things, right? Representing the null values and then finding a way to decode this null value. Let's say that now we are taking the null into the picture. So how will be this given tree look like? Now we visit A, okay? And the logic remains same, root left, right? We visit A, then we visit B. We put B over here, right? And over here, we will see that, hey, C also exists. And we will also traverse on the left hand side and we will visit C. But this time we will use the null values as well. So this will be null because the left of the C is null, right of the C is null, right? So it means now we are properly able to represent the left side of this A. Now, if we want to represent, now we have represented this C. Now we need to represent similarly for the D node as well. So same thing applies for the D node, and we construct this. This is just the continuation, right? I cannot fill up the board, and the next continuation will be null. So right now we have expressed this tree into a complete string format. And what we now we need to do is that somehow we need to tell the other computer to decode this. Okay. Now, if the other computer starts decoding it, how will it look like? Okay. How will it look like? So now when it visit A, it will start traversing on the left hand side. Now it will discover that, hey, left hand side has another subtree below it. So I need to recursively construct that left hand side until I reach the null. So that is the point I will continue constructing this given left subtree of this root A. Same after constructing B and D, then only it will complete, and then start saying that, oh, now I will need to construct the right side of this given tree. Okay, and since the right side is null, we are not going to do anything. Just mark this, create a null node, and just append it to the given tree. So with this information very much clear, let's see how our code is gonna look like. So I mean, there are a lot of YouTube tutorials which will go back and say, hey, this is how the code is gonna work. They wanna use Q and something, but I will say that use something called a string, IO string stream, because this will help to all your append and all your append operation which you are eventually going to do. Because what is the append operation? Let's first try to understand that. Okay, because now what is this A? This A is some given value, right? We are transmitting values over this. We are transmitting values, and we are telling a way to computer 2 to decode these values. So let's say that we are now saying that, hey, A is some 10. Let's say that A was 10. Okay, I'm going to give some values over here. So after that, we will also add some space. Okay, why space? Because we will need to differentiate between A, B, C, null, right? We need to differentiate between that. So that's why we are going to add some spaces over here, because after adding spaces, then only it makes sense now. Then only it makes sense that, hey, this is how we are going to traverse this given tree. And for that given reason, we are going to use the IO string stream and O string stream and I string stream. So yeah, we are going to use that. And the way it works is that just you, for your information purpose, it maintains an internal buffer, and and it appends data to it efficiently, right? It appends the data to it efficiently. So every time when you recurse back, right, let's say that you are doing some recursion logic, you're using some recursion logic, and every time you generate and append this, and you take this given string, and then you append the root value, okay, root value, and then you what you do is that you go on the you call this recursion again, and then you go over the left hand side. So the problem with this, right? The problem is that you're doing an append operation. So this becomes very expensive as the size of the string grows up. So for that reason, for some reason I'm not going to depth. I will cover that in the next video how this iString stream is working efficiently. But for our case, the serialization will be performed in O of one operation, O of n, the time complexity. So that's how we are going to construct and serialize this given tree. So once the string has been constructed, let's see that how the serialization works. So as I have told over here, as I had told over here, we need some characters. We need to say that, hey, this is null. So for our use case, since we can use any given character, we are going to use a, what do you call this? Hash? Yeah, hash. I'm going to call it hash 2. So once we have done this, now what we are going to do is that we are going and filling up this value to the to our output buffer, and we append this root value and along with some spaces. And once we have done that, we are going to recurse back on the left and we are going to recurse back on the right. And we are just passing the out by reference so that we are not creating multiple copies on every single recursion call, which will again becomes space complexity heavy because each recursion stack will have its own copy of out values, right? So we need to ensure this thing. Now the next thing which you need to understand over here is that once we have created this, we are going to return in the format of a string. So this is the way that out.str, this is the way you're going to return the serialization. So at the end, you will get something like this only, but what will happen is that instead of null, I might even write it down because I have A, B, C. We are going hash, hash, D, hash, hash, and finally hash. So this is how it's gonna be working out. Now, since we have represented this tree, okay, obviously there will be spaces over here which I have not shown over here, but there will be spaces, guys. Because if you club A and B together and you do not give spaces, the computer C2 will see that, hey, A, B are single value. I might, if this was 10, if this was 20, your computer C2 will say that, hey, this is 1020. Thank you. And that's where we get messed up. So let's not try to do that. So now the whole logic, the same way which we have serialized this given tree, the same way we are going to deserialize this given tree. Now, one thing to understand over here is that during the deserialization, I'm just doing nothing, but I'm just calling the, we need to see, the first thing is that we will be transported with some data. And for this given purpose, although I had initially started using the indexes, but I found out that index was actually not helpful for me. So I rather thought that, okay, why not we use the iString method or iString stream method over here. So again, what we are eventually going to do over here is that we are constructing a string value, and okay, this string stream, right? This is automatically when you right shift, right, you will automatically get the b value over here, or c value, something like that, anything which can eventually get. Just think that it works very well with the spaces. Like if you have a text document with, hey, Aniket is spaces awesome, and if my iron, I keep doing iron, well, I will first get Aniket, then it will skip the spaces, I will get is, and again it will skip spaces, I will get this. So that's how it's eventually going to work. Now what is going to happen over here is that if the current value is hash, I'm going to return a null pointer because that's what we have said over here. This represents a null pointer and we are reconstructing this given tree back. Now what we will do is that once we have reconstructed it, remember one thing, guys, remember the one thing which all students, this is a string value, this is a string value, right? Now any value, even the number value, what students actually mistakes over here is that they think that, hey, this is 12, let me just start directly appending the 12. But try to understand, once you have serialized it, it is in the format of a given string. So you need to take care of that, and you create a new node. You create a new node and you go to the left hand side, and then you go to the right hand side, and then you return the node. So this is as simple as that. And once you do this entire operation, I mean, this is nothing fancy, guys. This is really nothing fancy. And once you do this, and once you submit it, and then you see the code running, and obviously there is some failure. I think so I messed it up or something. Yeah, this might be the original code, but don't worry, guys. This is the same code, and I'm going to show you something might have happened because I was just playing around for a bit, trying to optimize it further. So apparently, both are the same code itself. Do not need to worry about. and there might be small mistake over here and there, but apparently this code runs pretty well, and you do not need to carry out the heavy logic of the entire you do not need to use the queues or something like that, and this is the pretty best approach which can actually come up during the interview. So I guess you enjoyed the video. Thanks. Do like and share with your friends if you enjoyed it. That's all for me.